All right, so here we start. This is 3.5, addition and subtraction of matrices. 3.5.
Do you ever give us unit tests over everything so far, or no? Is that not a thing? Okay.
No, I'm struggling trying to get y'all to pass half of one. So, no, I'm not.
Oh, thank you.
I used to, but not here.
I would fail those unit tests.
Me too.
I don't know.
Not you want it. Yeah, because then I have to do everything. That's 3.5 chapters.
No.
If there were mere Montana.
Okay, add and subtract.
Oh, we gonna do like 1 plus 1?
I think you should just leave it at that. Just add and subtract.
Matrices.
No. Get rid of that other word. Just
Okay, add and subtract matrices. All right, it's going to be good. So the first thing I need to educate you about is some vocabulary. Okay, some vocabulary. So I'm going to be using some words that maybe you haven't heard before. All right. So the first one is a matrix. Now I know you've heard of a matrix before, but we're not talking about Keanu Reeves swirling around and stomping bullets. Okay.
What are you all talking?
I've never seen a
Matrix.
What?
No. When I think of Matrix, I think of Wreck-It Ralph and like
What? Never mind.
Maybe I don't know what
Okay.
Matrix is.
So here it is. This is what a matrix is in math. It is a rectangular. Now look, is a square a rectangle?
No.
Yes.
But not all rectangular squares.
That's right. A square is a very specific and special rectangle. Okay, he's a rectangle with 4 congruent sides. All right, so a square is a rectangle, but it's a rectangular array. Now this word gives some kids a problem. Y'all, an array is simply an arrangement. Okay, and a rectangular arrangement, but they're going to call it array in the math book because they're technical. All right, array of numbers. Oh, so like you just take some numbers and you arrange them in a rectangle. There you go. That is a matrix. The dimensions. The dimensions. You have to know what to call a matrix, okay? And so we call it by its dimensions, and it is rows by columns. Rows by columns. Now, this is how I always tell the kids to remember. This is my husband's favorite drink. RC what? Cola. An RC Cola, rows by columns. So the first thing I want you to do right now is with your hands or your arms, please, people, put them in the air and show me how a row goes. Oh, y'all are scary.
Rows are this way.
Yeah.
Columns are this way like
Yeah.
my house.
A row goes
I thought they
across.
were the same thing.
A row is horizontal. A column is what holds the front porch up.
That's what
Okay.
rows are. You don't row both vertical.
Right. Alright, so rows are across, columns are up and down. Alright, one more thing. The numbers in a matrix are called elements. So when I'm talking about a number that's in my matrix, I'm going to call it an element, okay? This is the element on the second row in the third column, okay? This is the element on the first row in the second column. All right, so are you ready? So here is a matrix. First of all, when you write a matrix, it always begins and ends with a bracket, not a parentheses. If you put a parentheses there, I will count off for that. That is not a matrix, okay? So the matrix that I'm going to be talking about, on the first line, we have 4, -1, and 5. And on the second line, we have 0, 6, and 3. You do not put commas between the numbers, and you do not put dollar signs or anything else in a matrix. What is the only thing in a matrix?
Numbers.
A number, people. Don't be putting other junk in there. Okay? So, here's what I want to know. Can you tell me the size of this matrix? Don't say it out loud. Can you tell me the size of this matrix? Here's what you're looking at, people.
Big?
Thank you, Michael. That was so informative.
Is that the answer?
No. Okay. So, how many rows does this guy have?
2.
2 rows. 1 row, 2 rows. So he is a 2 by how many columns? 3. 1, 2, 3. He's a 2 by 3. Okay? A 2 by 3. All right. Here's your next one. Are you ready? This is matrix B. The first row is A, B, C. What? The second row is, guess what? D, E, F.
Why you gotta put letters in there?
It's still a 2 by 3.
It's still a 2 by 3. It is still a 2 by 3. Now, what if I tell you this? What if I say, hey guys, matrix A is equal to matrix B? Now, if they're equal, they're the same thing, right? So tell me what A would have to be.
4.
Yeah.
Huh?
Tell me what B would have to be.
-1.
-1. Are you getting it?
Yeah.
Tell me what
Got it.
C would have to be.
5.
It's who's in his place, guys. You're in the same place. This is row 1, column 1, row 1, column 1. This is row 1, column 2, row 1, column 2. Row 1, column 3, row 1, column 3. Okay? So, now you know what's D.
0.
And what's E
6.
and F. Very good. All right, anybody got a question so far?
No.
Okay, so let's add and subtract some matrices. Are you ready?
No.
Yes, this is good, y'all. This is fun, I promise. And tomorrow, oh my word, we're gonna have so much fun multiplying matrices. Are you coordinated?
Barely.
Oh, if you're
I
not
can pat
coordinated.
and rub.
Oh, well then you're coordinated. Okay, so this is what you have to do to multiply matrices. This left hand has to go, across while the right hand goes down. So it has to go like this.
Well, we're doing add and subtract. We're not there yet.
We're not there yet.
Like this.
So you might want to practice this at home tonight. This one goes across, but this one goes down.
Wait.
I did again? Oh,
Oh my word.
Y'all.
Come on, y'all.
Hey, it's like
Am I
hey, it's like
doing
with
it?
this things they do where this hand goes in a triangle and this one goes in an L, so you're going like this.
That's a drum exercise.
Okay, so like Lauren said, we're going to add and subtract. Okay? So to add and subtract matrices. You will tomorrow.
Is matrices multiple matrices?
Yes, matrices is plural for matrix.
Okay, good.
You know those dang English people, they're always like, you can't just like put an S on it, you gotta change all kinds of mess, right? Okay, so to add and subtract matrices, first of all, they must be the same size. Okay, so if they tell you to add a 2 by 3 to a 1 by 4, what are you gonna say?
No.
Not possible. But you have to tell me why. Why is it not possible?
Don't have the same.
They're not the same size, right? They're not the same size. They have to be the same size. They're not the same size. You can't add them. Okay? So anytime something's not possible, you have to tell me why or you lose 2 points. Okay? So it's like a freebie question, but you gotta tell me why. So must be the same size. And all you're going to do is add. Notice I don't ever use that word subtract. All you're going to do is add corresponding elements. Add corresponding elements. Okay? So, I mean, I think we need to try one, right?
I just think it'll work. We'll do it.
No. Okay. So here we go. Here's yours. You ready? My first row is 3, 0. And my second row is -5, -1. Matthew? Right. Plus, my second matrix is -1, 4, and 2, 0. Y'all, this is very logical. Okay, it's very logical. If they're in the same place, they need to be collected. Okay, if I'm gonna add this matrix to this matrix, if those numbers are in the same place, you collect them and you write them. Now, what size is this?
2 by 2.
Man, you can't mess that up, can you? Okay, 2 by 2. It doesn't matter which one you were calling, it's a 2 by 2. All right? So when I add a 2 by 2 and a 2 by 2, guess what I get?
A 4 by 4.
A 2 by 2.
Oh, 4. 2 times 2.
Okay,
Oh,
watch
times 2
this.
times 8.
Watch this.
I got it, babe.
Look, right here, row 1, column 1. Row 1, column 1, row 1, column 1. What's 3 and negative 1?
2.
2. What's 0 and 4?
4.
Find the bottom row.
Easy.
Find the bottom row.
Oh, wait.
And,
I remember reading about
Very good. Okay, so here's what you should have gotten. On the second row, negative 5 and 2 make negative 3, and negative 1 and 0 make negative 1. So there's my answer. Anybody got a question?
That's it? I like
Okay,
it.
that's it. I could work 100 problems, but they're all just the same. I could make them different sizes, but it's still, if they're in the same place in the matrix, then I add them and write their answer down. Okay? So, how are we going to subtract
Same thing.
if all I can do is add? So, to subtract matrices,
Who said all you had to do was add?
look, it says right there.
Wait, oh.
To add and subtract, you add corresponding elements. Okay? So, to subtract, does anybody know what the definition of subtract is? To add the what?
Difference.
Opposite. That's exactly right. To add the opposite. So right now, some people are going, oh, I know what we're going to do. We're going to change that subtraction sign to an add sign, and we're going to do what to all the members of the matrix? Change their signs. That's exactly right. All right, so here we go. The first matrix, I'm going to draw a 3 by 2. Okay, I'm going to draw a 3 by 2. All right, so here we go. The first row is 7, 4. The second row is 0, negative 2. The third row is negative 1, 6. To that matrix, I'm going to subtract, or from that matrix, I'm going to subtract negative 2, 5, 3, negative 10, negative 3, 1. Okay? Now, what did we say we're going to do? Add the opposite. So what am I going to change this to?
Plus.
And do what to all these guys? Now let me explain to you why we're doing this. If I left this as a minus sign, and I said, hey guys, when you subtract these two, what do you get?
a negative.
Yeah, you get 9. How many people look at these two numbers right here and go, oh, that's 9? Yeah, there's some of us that do, some of us that do, and some of us are like going, 9? Where do they get 9? Okay, so that's why this is the easiest way to do it. Make it a plus sign, and then change all these signs right here. What does negative 2 become? What does positive 5 become?
Negative.
What is positive 3? And then positive 10, positive 3, and negative 1. And now we can just add them, okay? So my first row becomes what? 9, negative 1. What does my second row become?
Negative 3.
You find the last row.
Are we getting a worksheet today or?
So how does this get hard? Yeah, how does this get hard?
Okay, calm down.
Yeah, or you make it
I'm kind of confused.
All right, so the last row, what'd you get? 2, 5. Very good. Does anybody have a question? Okay, when did I say it was going to get difficult? When we do multiplication. Okay, multiplication is it's harder. All right, so here's the next thing. The next thing, we got another vocabulary word. It's called a scalar. Every time I write this word, I think it's wrong.
It's in a business school.
Okay?
It's a name of.
A dentist tool. Okay, now that's an ER instead of an AR. All right, so a scalar. A scalar is a number in front of a matrix and multiplied by the matrix. Okay, so I'm going to draw a picture. I'm going to show you what it looks like, and you're going to know exactly what to do. Even if I hadn't told you, you'll be like, oh, I know what I'm supposed to do here. So there's my scalar, like big giant -2, okay? And then I got a little matrix over here. 3, 0, -6, 5, 1, -10.
Oh.
Okay, now what does your brain tell you that you probably need to do?
Multiply by each
Yeah, it says a number beside any symbol with nothing in between means multiplication. So, does that mean, oh, I only multiply the middle row by it, because that's who he's by?
No, everybody.
No, everybody gets multiplied by it. And so my matrix becomes, what's -2 times 3?
-6.
What's -2 times 0? There's going to be a common mistake right there. People are going to write -2. No? All right, you do the rest of it. While you do the rest of it, I'm going to tell you how I grade matrices. I grade matrices like this. If you miss one number, do you see how it might be easy to miss one number?
Yeah.
Like you do something stupid like this. -2 times 0 is -2. -2 times -6 is 12. -2 times 5 is -10. You see what I'm saying? And I missed that one number. If you miss one number, you lose half credit. If you miss more than one, you lose all the credit.
Ooh.
Okay? So I give you a little bit of break. It's not like right or wrong. Now, if we're using a calculator, it's right or wrong. Okay? And I'm going to tell you this. If you put it in the calculator wrong, it'll come out wrong. Okay? So, all right. Multiply here, -2 and +20. Did everybody get that? Okay, so let's add a little difficulty to it. Okay? Oh my word, this one's going to be so hard. 4 times -2, -8, 5, 0. Minus 3, -8, -6, 5. There's my problem.
Are we
Does
working
this
that
problem
first?
right here look like, does it look like this? 4 times, I don't know, something,
X.
minus 1.
Yep.
Does this look just the same as this?
Yep.
Now this is a transfer of knowledge. That's what that's called. If you know how to do this, you ought to know how to do this, right? What do you do first up here?
Distribute.
I like
Multiply.
Okay, I multiply. Do I distribute that 4 to everybody?
No.
No. It would have to have big parentheses around the 6 and the -1, right? In order to distribute it. Okay? So, who gets multiplied by the 4? And do I do that first?
Yes.
Yes. So let's do that. You write your answer down. And go ahead and write the other part of the problem too. Okay, so on the first part, you should have gotten -8, -32, 20, 0. Is everybody okay? All right. Now, when I subtract, what did I tell you to do?
You have to change the sign?
Yeah. Make it a plus and change all the signs.
Are you gonna take out points if we don't do that?
No, I won't have to. You'll miss them.
Okay.
Okay?
I think I got it.
All right.
That's
So
okay.
what's
We don't do what?
-8 and -3? -8, -3. -11. What's -32 and +8? What's 20 and 6?
26.
What's 0 and -5? There's my answer. Anybody got a question? Okay, so let's talk about some properties, okay? Let's talk about some properties. Some properties that hold true with matrices. So here's one of them. If I take matrix A and I add it to matrix B, and then I add matrix C, I'll get the same thing as if I add B and C first, and then add A. Does anybody know what property this is?
Associates.
Associative. So what's your first clue?
That
They're in order. They're in the same order.
Yeah, and there's how many things?
3.
3 things, and they have to keep keep the order. ABC, ABC. So this is the associative property of addition. Okay? Here's another one. A plus B is the same thing as B plus A. So the order that I add those matrices in doesn't affect my answer. Okay? What's that called?
Identity property?
Nope.
Inverse?
Yes, that's commutative property of addition. That one flips. Okay, now y'all listen, this is the whole purpose of algebra. If you didn't know these right off the bat, when we said them and talked about them, could you retrieve that information?
Yeah.
Did you remember learning it? Y'all, that's what it's all about. It is not about knowing how to do everything that we cover in this class. It's about next year when the teacher says, hey, let's talk about some matrices. And you're like, oh, yeah, matrices. And she works one problem and you're like, oh my gosh, yeah, I remember. I know how to do those. Do you see what I'm saying? Not expecting you just to pull it up like that, but to file it somewhere so when someone reminds you and prods you, then you can pull that information. All right, here's the next one. See if you know this one. This is a number times matrix A plus B is the same as the number times A plus the number times B. Yeah, that's the distributive property. And it works for that subtraction also. Okay? Now, I'm skipping example 3. I'm going to do it tomorrow. I'm starting on example 4. I thought I would get finished, but I didn't in any class, so we'll just see. We are going to solve a matrix equation. All right? Solve a matrix equation. All right, so here it is. 3, open the big parentheses. My matrix is 5x and -2, 6, and -4. Plus, my next matrix is 3, 7, -5, -y. Close the matrix and close the parentheses.
That's not fun.
It equals the matrix -21, 15, 3, and -24. Okay, now it looks pretty messy, right? Okay, so what could I'm not going to do this, but what could I do right now to clean it up a little bit?
Distribute.
Yeah, you could distribute that 3, and that might clean it up for you a little visually. All right, but I'm not going to because I'm going to show you something else. Okay, obviously I'm solving an equation, so I'm looking for some variables. Here's a variable right here. Tell me who all goes with this 5x when I make an equation.
3.
A 3 and -21. So watch what I'm going to write down. Do I have to keep this 3 up here?
Yes.
Yes. So watch how I'm going to do. 3, open the parentheses, 5x plus 3, close them, and what does it equal? -21. Okay, so instead of distributing the 3, what could I do with that 3 to get rid of it? Yes, I could. Jacob says you can divide that dude out. All right, so he's gone here, and I'm left with 5x plus 3 is equal to, what's -21 divided by 3? -7. Now I'm solving for x. Tell me what to do.
Subtract 3.
Perfect. Is everybody okay? All right, so -3 minus 3. So 5x is equal to -10. What do I do?
And x equals, you divide by 5 and x.
Divide by 5, and x is what?
-2.
Okay, so let's go solve and figure out what y is. All right, here's my y right here. Who goes with this -y?
-4.
-4 and -24. Okay, now did you see what just adding a little color did to it for me?
Yeah.
Because that makes it tons easier. Okay, circling it with a colored pen is the same thing. All right, so I still got that 3 out there. -4 minus y. Would it be wrong to distribute the 3?
No.
No, you could do it that way. It's not a big deal. It's equal to -24. Divide by 3. -4 minus y is equal to -8. Now what do I do?
Add 4.
Add 4. Negative y is equal to negative 4. So what's y?
4.
Yeah, please, we're just changing the sign. All right, anybody got a question? Okay, so we like one problem. I'm gonna just go ahead and give you your worksheet tomorrow because they're not gonna be due for a while. So I think you'll have plenty of time to work on them. If you're going to a tutor or something tonight and you need it, you can come by at the end of school. I'll have to go pick them up next class period. Okay, they're in the print shop. Anybody got a question?
Do we make that like a point? We couldn't make it.
No, because we're not talking about coordinate planes and stuff.
So it's all.
It's just an X and a Y. Okay? Yep, that's it.
That's it.